how are you doing? Are you doing good? Yes, give me a thumbs up. Stay safe always, okay? Stay healthy. So today in this class, I'm going to discuss about the new Cartesian sign conventions for spherical mirrors, okay? I am Mahesh, your physics teacher, and you're watching my YouTube channel, SMR Online Physics. If you are new to this channel, please do not forget to subscribe my channel to get wonderful explanatory videos on various topics of physics. Alright? So, this is a continuation of my series of classes on the topic of light, reflection of light by plane and the spherical mirrors. So, if you haven't watched my previous videos, do sure to watch them. Okay, the links are given in the descriptions below. So let us continue our today's class. We will learn about the sign conventions for spherical mirrors and how to use them. Are we all ready for that? Great. So the topic is sign conventions. In your textbooks, it will be also printed as new Cartesian sign conventions. So basically, my students, sign conventions refers to you need to either put a plus sign or a minus sign depending or obeying certain set of rules. Is that clear? So it will be applicable for both spherical mirrors. So let me show you what are the rules like. Here I am trying to show you a concave mirror. And we'll learn how to apply the signs. Is that clear? Okay, let me quickly draw a ray diagram for a particular position of an object. This is valid for any position of the object, but just to illustrate the fact, I'd like to show you what are the various sign conventions. Alright? So, suppose I choose the position of the object as if it is standing between C and F. If it is standing between C and F, we all know that the image is going to form beyond C, real, inverted and magnified. Alright? So that's what I was saying. If you are not sure about these ray diagrams, how to construct ray diagrams, do watch my previous videos in which I have in detail explained how it can be done easily. And here I use another ray striking at the pole of the mirror, and there we go. Okay, good. So it always makes equal angles. So you can clearly see in this diagram, I've drawn a pretty clear and bigger diagram. The image is forming somewhere beyond C, which is truly the case. Alright? That's it. This is suppose the image formed of this object. So let us quickly name the object AB. So the image has to be A dash B dash. So before understanding all the signs required, let me just tell you all the distances concerned here. If you observe the diagram closely, the distance from pole to the focus, this tiny length of the mirror is extremely critical property of the mirror, that is called as the focal length of the mirror, denoted by smaller f. Alright, then the next one is called PC, pole to the center of curvature. This longer piece of distance is called correctly as radius of curvature. Okay, good. And we have some more distances going up. From pole to the base of the object where the object is standing, that is PB. This PB is called as the object distance, or to clearly illustrate, it is the distance of the object from the pole of the mirror, basically denoted by the alphabet U. Yes, radius of curvature is denoted by capital R. And we have one more distance which can be measured parallel to the principal axis, that is from pole to the base of the image where the image is exactly formed. So this is my B dash, P B dash. From pole to B dash, we will call it as image distance. Image distance is denoted by the alphabet smaller v. Is that clear? These are the four major distances which can be measured parallel to the principal axis, and every one of you should know it clear. Alright. There are two more distances which can be easily measured in this case. One is the height of the object. This vertical height of the object. Is that understood? So in this case we will name it as AB. I will name it as AB, but I will not measure this way. I will try to always visualize that height measured from B to A. That is perpendicular to the principal axis and above. Since it is measured perpendicular and above, or AB, in terms of length the measurement would have been same. This is what we call as height of the object. Height of the object, also referred to as size of the object, denoted by the alphabet H. Similarly, there is an image formed. This is the image formed A dash B dash. So there is no surprise, you have already guessed it. We will call it as height of the image. So these are the total 6 distances which we need to really take care of. This is denoted by H prime. Okay, we will put a H dash. That will be called as the height of the image. Now we get ready to understand the sign conventions. I think everybody has noted it down. You have understood the various distances. These 4, as you can see, all are measured parallel to the principal axis, and these 2 are measured perpendicular above and perpendicularly below the principal axis. Alright, so what are the sign conventions? What are the sign conventions? We need to apply, my dear students, this plus or minus sign only for these 6 distances. So where to put in the plus and where to put in the minus is the major trick. Okay, please pay some attention. Okay, let me just show you sign conventions which are very easy and applicable for both the spherical mirrors. This is your concave mirror, or it could have been equally applicable for convex mirror. So let me show you both at the same time. Alright, now let me draw the principal axis passing right through it. For the concave mirror, this is pole, this is your focus, this is your center of curvature. And similarly for a convex mirror, you can clearly see that this is your pole, this is your focus, this is your center of curvature, which is on the right hand side. Alright? Okay, good. What the sign conventions, as I said, in most of the books it is also given as New Cartesian sign conventions. The word Cartesian the word Cartesian comes from the French mathematician's name René Descartes. Okay, René Descartes. You can see this Cartes. This is called Cartesian. Clear? So it's very commonly learned in coordinate geometry how to draw x and y axis and how to really read the graphs and how to really plot a graph. So let me just show you here. Idea is very simple. We all are familiar about x and y axis and the coordinates. So if this is my x prime axis, if this is my y prime axis, this is the origin, and everyone knows that the coordinates of the origin is 0, 0. Alright. Now if I move to the right side from the origin, every length is a positive length. So anything measured from the origin to the right side is a positive length. Anything measured from the origin to the left of it is a negative length. Is that clear? Good. From the origin, any measurement done above, perpendicularly above, is a positive length, or any measurement done from the origin below is a negative length. So my dear students, all we need to do is plot this, or just take this and put it or imprint it on our spherical mirrors. As simple as that. So now I'll take up this x and y axis and put it over my spherical mirrors. So let me do it for you. Suppose I place something like this for a concave mirror. So this is my y dash, and the principal axis itself will behave like x dash axis. As simple as that. Are you getting me clear? I just put it up there. Now listen carefully how you're going to use this Cartesian coordinate system for your spherical mirrors. Extremely important to know and understand before solving the problems. Clear? So rule number one says that whether you are dealing with concave mirror or convex mirror, just intentionally place the reflecting surface of the mirror towards your left side. It should be facing towards your left side. अपने आईने को अपने left की ओर face करते हुए रख लो. That's it. As simple as that. All right. This should be facing towards the left. Rule number 1. Now rule number 2 says any measurement done or need to be done parallel to the principal axis need to be done from the pole of the mirror. So pole will be considered as our origin. Pole will become our origin. That is our rule number 2. Simple. Rule number 3 says any measurement done parallel to the principal axis and measured from the pole to the right side. Any measurement done from the pole and parallel to the principal axis to the right side, in both the cases should be given a positive sign. Similarly, any measurement done from the pole towards its left side should be given as a negative sign. In both the cases, it is true. If you are measuring from pole to the right plus, pole to the left minus. Any measurements done above the principal axis, that is perpendicular and above the principal axis, put a positive sign, or any measurement done from the principal axis and below, put a negative sign. I hope it's very, very clear. Alright? I hope it's really clear to everyone. Any measurement done above the principal axis is positive. Any measurement done below the principal axis should be negative. Is that clear? So now let me draw a ray diagram as a sample ray diagram, and let us quickly practice how to really use the sign conventions. Okay? This is a concave mirror, for example. This is your pole of the mirror. This is your focus. This is your center of curvature. Okay, this is a very good example. If the object would have been standing between C and F, as I have already shown you all the distances right at the beginning, I just quickly draw this diagram, and you can see that the image forms somewhere beyond the C. Somewhere beyond the C. Alright. So if this is my object AB, and if this is your A dash, B dash. So you know the properties very well. A dash, B dash is the image and everything else. Alright. Now let us quickly learn how to apply the sign conventions. PF, we call it as focal length. So if you observe, this is the distance measured from the pole to the left hand side of the pole. So it is a left side, so I should be putting a minus sign. My dear students, it's time to really be alert at this point to learn how to put this plus and minus. Since the distance is to the left side, minus sign. Again, the next distance we are talking about is PC, that is called radius of curvature. So I know it, radius of curvature. Again, you see, the distance is measured from the pole to the left hand side. So it's a minus sign. Alright. Again, PB, pole to the base of the object. Again, it is a distance measured to the left hand side. So it should be again minus U. Pole to the base of the image. That is P, B dash. So it should be again to the left hand side. So it will be again minus. Is that clear? So these are the four distances which are measured parallel to the principal axis, but in this case all were measured to the left hand side, so it is a minus sign. Now you look into this case AB. If you look into this distance AB, it is measured above the principal axis, so it should be plus H. perpendicular and above, so plus h, or you will have a dash, b dash, the height of the image measured perpendicularly below the principal axis, so it should be minus h dash. Is that understood? That is the way we can use the sign conventions. I hope I am very clear. In this way you can do for any position of concave mirror, any position of convex mirrors. Okay, note it down please. Now let me show one sample diagram for convex mirrors to make you really feel comfortable. Convex mirror. As I said, always make it sure you draw it or practice it in such a way that the reflecting surface is facing towards the left side. So this is my pole, this is the focus, this is the center of curvature. Suppose we choose this position where the object is placed between infinity and the pole of the mirror. So you'll find the light will strike the mirror, they bounce off from the focus, they seem to diverge as everybody knows it right now, and strikes at the pole, bounces off. So if you produce these rays backward, they intersect at this point and image is formed. So AB is the object, A dash, B dash is the image. Is that clear, my dear students? Right. Can you pause this video and try for the sign conventions of all the 6 distances? It would be really good. Then you can play it and check for the correct answers. The correct answers or the correct signs would have been something like this. If you are looking for PF, the focal length of this convex mirror, observe closely, it is to the right side of the pole. So since the distance has to be measured to the right side of the pole, the sign will be positive of F. Similarly, from P to the C, the center of curvature, PC, which is radius of curvature, in this case the distance is again lying to the right hand side, so the sign has to be plus once again. From P now to the base of the object, very interesting, the object is on the left hand side as always because the mirror is facing towards the left hand side. So this distance PB will be taken with minus of u because the distance is measured from pole to the left hand side. If you are measuring any distance from the pole to the right hand side of the mirror, that is PB dash in this case, the image distance, this distance in this case would be positive of V. Am I clear, my dear? This will be plus V in that case. Similarly, AB, which is height of the object, just like in the previous case, it is a distance measured above the principal axis, so it should be positive of H. Similarly, very interesting is A dash B dash. Here you will find it is also a distance measured above the principal axis, so positive of A dash. So if you compare the sign conventions with the sign conventions of concave mirrors, what I just showed you, you will find there are some differences and there are some similarities also. And the similarities always remain same. They should be neatly kept in your head because they will always carry the same sign. Can you guess which two quantities carry the same sign? You should be, yes, the object distance u and the height of the object will be always carrying the same sign irrespective of the mirror. Object distance is always negative, height of the object is always positive. I hope I am very clear. Now I would like to show you the mathematical formula. Then also in this class I'll teach you how to derive the formulas very easily. Alright? So what are the various relations applicable for spherical mirrors? Let me write it here. Right. Let me use this corner to write down the formula. Okay. The relation number 1. The relation between the focal length and the radius of curvature. So my dear students, for spherical mirrors with very smaller apertures, you will be always noting down that the focal length is approximately half the length of radius of curvature. So the relation is F is equals to R by 2. Focal length is half of radius of curvature, applicable for both the mirrors with small apertures. So you could have remembered any version you liked it. R equals 2F, that is also correct. Number 2, the most important one, is called as mirror formula. This is called mirror formula. Mirror formula is applicable for mostly for our concave and convex mirrors. Alright. So the formula looks something like this. I just kept these distances for you so that you do not have to really forget what I am talking here. So here I am writing 1 by V plus 1 by U is equals to 1 by F. This is our mirror formula, the very important formula. So let me put it in a box. So I think most of you recognize that's the purpose why I did not rub off this diagram. 1 by V, image distance, plus 1 by object distance is equals to 1 by focal length. This is called as the mirror formula. Now I am very quickly going to show you how to really get to that formula. How did we exactly derive that formula? Alright. And relation number 3. The relation number 3 is for magnification. To really know how many times the image is magnified or diminished, or is it of same size, we can just quickly get the answer using this simple mathematics. Magnification denoted by smaller m, and it is defined as h dash by h. So h dash by h, you can clearly see the distances are here, nothing to confuse up. So h dash is our height of the image, h is our height of the object. So since it is a ratio of similar quantities, the units will get cancelled off, and magnification is a pure number, it doesn't have any units. But my dear students, magnification could be also represented by the equation minus of V by U. This is not a sign convention, this is a part of the formula. Alright. Minus image distance by the object distance is also gives us magnification. Right. So if this is clear to you, then you can clearly see that both the left hand sides are exactly the same, so right hand sides can also be written as equal. Hence I write it here. You can write h dash by h should be equal to minus V by U. Is that clear to all of you? H dash by h is equals to minus V by U. So coming from this formula. The simplest trick to remember these pluses and minuses is, in the mirror formula there is a plus. So in the magnification does the opposite, there is a minus. Later on we will discuss lenses, very similar kind of a formula we are going to achieve. Alright, please note it down here. Alright, I think I am very clear till this point. Okay, thank you. Right, please.